Okay, let's start out with section 1 in chapter 1, an introduction to graphing. So we're going to go through how to plot points, how to figure out if an ordered pair, aka a point, is a solution to an equation. We're going to find intercepts on a graph so we can then graph equations. Use the distance formula, which you will see in turn will go into circles. So let's do it. Here is our Cartesian coordinate system where most students, take a class like this, and with graphing, they're like, I've never seen graphs look like this. Typically they do, but they only show you quadrant 1 because everything's positive, like your bank account, right? And so it's good to understand, though, with graphing that if you're in quadrant 1, you went to the right, you went up, that your x and y value are both positive. If you went to the left, now you're dealing with a negative x value, but y is still positive. If you went to the left and down, both x and y is negative. Doesn't it look like that's a person winking to you, right? And then quadrant 4, the x is positive, but you went down, y is negative. So it's just good to understand when you see the signs on your coordinates, your xy point, to be able to figure out which quadrant you're in and how to plot a point. So plotting points, the first value is our x, so that shows -3, so we're going to go to the left. Remember, x is the horizontal, left and right, right if it's positive, and then the y is the vertical, +5, because you're going up, and boom, you put a point right there, and that's pretty much it. When we want to graph an equation, typically we like to first see if an ordered pair, this xy point, is actually even a solution. So all you do when you have an equation like this is you just simply check it by plugging in this -5,7 for x, for y, and you see if the left side equals the right side. They do not, so this is not a solution. What if we want to try x equals 3 and y equals 4? This is a solution. The left and the right are equal. So you just simply plug in actual values. Now, if we want to actually graph an equation, if we're given an equation, we want to graph it. I know we all pick up calculators, graphing calculators, and we will do that in here in Desmos, but there's actually a very quick way to graph. First thing is you find the intercepts, where the x-intercept is where you went left and right, so you're on that horizontal x-axis, but you didn't go up or down, so the y equals 0. And we can simply find an x-intercept very quickly. If I have this equation, 2x plus 3y equals 18, I let y equal 0, and I solve for x. So this tells me the point where it crosses the x-axis. I can do the same thing with a y-intercept, but now the x value is 0. So I put in 0 for x, and I solve for y, and I get these 2 points. And it's always nice to typically get even a third point. And you can plug in, students always ask, well, why did you put x equals 3? Because I wanted to. You could put any number you want, but then you have to solve for y, right? So I put in 3 because this works out nicely and I didn't get them weird fractions. And when I plug in 3, I get y equals 4, and thus I can even see now that point is on this line. You can very quickly graph by the intercepts. And you see these a lot. Students will make tables that let x equal 0 and then solve for y. Let x equals 9 and then solve for y. Let x equals 3. You hear me? What I'm saying? Solve for. We're not just picking for. We had to actually solve for it. And you can do any type. We're going to look at different types of graphs. But once you have an equation, you just pick a value for x, and you can do as many points as you want. Pick a value for x and then solve for y, because it's easier to plug values in here. And if you can, and we'll talk about that a little bit later. What do I mean? If you can, always pick 0. 0 is a great number unless it's your grade, right? Oh, we don't want to go there. All right, the distance formula. We can look at the distance between 2 points. So this first point we're going to call x1, y1. The second point we're going to call x2, y2. And you can see we find the difference between the x's, square it, and then the difference between the y's and square it. Once we do that, we add them, take the square root, and we can find the distance. So here is an actual example of 2 points, and I found the distance here by taking the differences in my x's and my y's, squaring those, and then taking the square root. We then come to the midpoint formula, where what if we want to know what this value right here in the middle is? We add so we have 2 points. We add the x's, and then we divide by 2. And then we add the y's, and we divide by 2. So as you can see in something of this, I take -4 plus 2, because those are my x's, then -2 plus 5, and then I graph it. Always plot stuff, because if your math is bad and then you plot it and it's over here somewhere, you're like, oopsie. So always graph everything you can when you have these equations to check them. And then the distance formula, as you saw, kind of comes in here with the equation of a circle. This is nice, the middle right here. So if we're looking at our midpoint, we can actually find this based on our radius, and the radius is from the middle to anywhere on the graph. That will be the same distance. If I doubled that, you might have heard the diameter. And so it's easy if you're given a point to come up with where you would draw the graph of a circle. So the equation that I'm given here is with the center at HK. So that's the center right there, that HK. And then as you can see, my radius. All right, so we can look at an example. If we are given the center point and a radius of 5, we simply plug in our HK. So you can see H, 3, and then our K, -7. Notice it's a minus, so that's going to be a plus, and then our radius, r squared, which becomes 25. And if you actually graphed this, you threw this in your graphing calculator, you would see it would be a circle.